Okay, students, class 9 students. Today we will study about law of conservation of energy. Actually, these days our chapter is work, energy, and power. So, in this chapter, the important point is law of conservation of energy that we have to study today. So, what is law of conservation of energy, and how it gives the idea that total energy remains conserved every time. So what is law of conservation of energy? We will study. Law of conservation of energy. First we will write a statement. Total energy remains constant of any isolated system, or we can say energy can neither be created nor it can be destroyed. Only it can be transformed from one form to another. From one form to another. That means energy is not produced anytime, not created, nor it can be destroyed. We cannot destroy energy. Only we can change its form, maybe from chemical to electrical, or from electrical to mechanical, or from mechanical to electrical. There are different cases of this change, and that we observe in everyday life. Like in electric generator. What happens in electric generator? In electric generator, actually mechanical energy is converted into electrical energy. And what happens in electric motor? In electric motor, electrical energy is converted into mechanical energy. Now take about solar cells. Solar cell uses solar energy to convert into electrical energy. So solar cells are charged first by sun light, and then the energy is stored in the form of electrical energy that could be used further. So this is true with any two form of energy. Like in battery. In battery, chemical energy is there that could be converted into electrical energy. So this is a very common law of conservation of energy. We can prove this statement in case of freely falling body. What happens? Maybe let us consider that from the ground, from the earth's surface, at a height h, an object is placed at point A. This object has got mass m. So here it is placed, it is a state of rest. So before falling down, if we will calculate the total energy at this point, it will be only the potential energy, because no kinetic energy is there. So if you are talking about the object which is at height h, so it has got potential energy mg h. So let us calculate the energy of this ball at point A. Place at a height h from the ground surface, from the surface of earth. Now total energy at this point A is sum of kinetic energy and potential energy. So what is kinetic energy actually? Kinetic energy formula half mva square. But Va at this point Va is 0 because it is a state of rest. But what is potential energy? It is mgh because at a height h the object is located. So when we talk about it is 0 plus mgh.
देखिए पापा देखिए
अच्छा गुड
मुन्नी भैया फरा दी
वाह उसको धागा से बांध लो. सो ये टोटल एनर्जी एट पॉइंट ए. देखिए कितना बड़ा बैलून हुआ है. टोटल एनर्जी एट ए is equal to mgh. Here we have got the first point. Now maybe this ball is allowed to fall, and maybe after falling through x distance it reaches point B, and maybe the speed at point B we can calculate here. So what happens at point B, the height of the object is decreased. It becomes h minus x. Due to this less height, potential energy decreases. But what increases? Kinetic energy increases. So loss in potential energy is actually gaining kinetic energy. So total energy at this point we will prove that it will also remain same mgh. So now let us consider total energy at point B. Now let the object is allowed to fall through distance x. So the falling object will gain speed due to gravity. If Vb is the speed of the body at point B, then total energy at point B is the sum of kinetic energy at point B plus potential energy at point B. So kinetic energy, if we are talking, half m Vb square. Potential energy mg. Now height is h minus x. So what is Vb here? We will put the value of Vb because initial velocity is 0, final velocity Vb. Under gravity, that means acceleration is working plus g. So from third equation of motion, final velocity v square is equal to u square plus 2as. V square means final speed, that is at v. Initial speed, that is at a. And 2gx, because through x distance it has traveled. So what is this Vb that we are going to calculate? At Va it is 0. So you can see Vv square, in place we can write, that is 2gx. Using this in above, we can put Vv half m into 2gx, that is coming Vb square, plus mgh, breaking this bracket, mgh minus mgx. Now this 2 to cancel. So it is mgh minus mgx plus mgx cancel, and we get total energy at point B is also coming mgh. So we have proved that at point A the total energy of the ball was mgh, and after falling through a distance x, also if it reaches point B, it is h minus x height from the surface, but total energy remains same, put mgh. That is quite interesting. So now again it is allowed to fall, and it reaches at the lowest point before hitting the surface of the earth at point C. So here the height from the earth is approximately negligible, 0. So mg into 0, that will be potential energy 0. So potential energy depends on location, system, height. We can write 0. But if it is allowed to fall through this height, at this point C, it will get more kinetic energy. How it can get more kinetic energy? That means speed at point C, if we will calculate, it is in the direction of motion Vb. So we are writing total energy at C is the sum of kinetic energy because potential energy is approximately 0. So kinetic energy of C is the total energy at C. Now body is allowed to fall again and reaches the bottom point just above the surface of Earth. So total energy at C is total energy means kinetic energy at C plus potential energy at C. Potential energy is height 0. Height 0 so no potential energy. mgh. Kinetic energy is half mv. Now we can calculate Vc from that same diagram. So how to calculate Vc? What happens? Object has fallen through a height h to reach here. So initial velocity is 0 and maybe the velocity at C is Vc, and when it reaches after traveling h height, so initial final displacement. Third equation of motion again we will like. Final velocity, initial velocity plus, that means Va square is initial velocity square plus 2g displacement is h. Initial velocity is 0. Now putting the value Vc here, that is 2gh plus potential energy mgh. Here what we have seen, h is approximately 0, so mg into 0, that is 0. So what we are doing, here we are writing mg into 0, potential energy at point C is 0. Two cancel mg h and mg into 0 0. So what we see, total energy at point C is also coming mg h. So hence we can say that total energy of the ball at point A is mgh, at point B is also mgh, and at C is also mgh. Hence खाना पड़ोसी हो गया मेरा. Hence total energy remains same throughout its motion Hence, total energy remains same throughout its motion. So, law of conservation of energy is proved. Okay, students, for today we are leaving it. We have proved law of conservation of energy. Okay, this is the proof what we studied. Okay, students, class 9.